Section 2.2 talks about limits. Now, what a limit is getting very close to a number but never reaching. So when we say, let f of x equal x squared, x minus 1 over x squared minus 1. Find the limit of f of x. Find the limit of this y, which is this, as x approaches 1. So if I put 1 on a number line, the idea is pick values close to 1 and see what y is approaching. So let me start with some values. Let's say I'm going to go from 1. I'm going to say there's x, there's f of x. So I'm going to check 0. Then a number a bit closer, 0.5, because 1 or 2 values are useless. So if I go ahead now, if you have a scientific calculator, unfortunately I had a scientific calculator, but my membership expired with it, so I can no longer use it. So I'm going to use what I have. So the way it works, notice if it says 0, I'm going to substitute 0 minus 1 over 0 squared minus 1. If it's 0.5, I'm going to substitute 0.5 minus 1 over 0.5 squared minus 1. If you notice, and this is going to happen a lot in our class, we're going to evaluate a lot of values. And if I'm doing the same thing over and over, I'm going to make use of my answer key on my calculator. And let me demonstrate. So instead of me doing parentheses 0 minus 1, okay, 0.5, 0 and 0 minus 1 divided by 0 squared minus 1. I'll get a 1. And since I have to do the same thing again, I could say 0.5 minus 1 divided by 0.5 squared minus 1. 0.666. Notice it's a lot more efficient for me to say, well, look, there's this answer key that I have. Since the only thing that's changing is the 0 and the 0.5, but it's the same mark. So if you look at the PDF, the shaded yellow part, if I take 0 and enter it, it's stored in this key, answer. In a scientific calculator, the key will be right there. 0 stored in the answer. If I am to go ahead now, and instead of putting 0 and 0.5 and all of these different values, I'm going to evaluate, because I'm going to go for 0.1 next. Then a number, I'm sorry, 0.9, and 0.99, and 0.999, and 0.9999. So the goal is, how close can I get to 1? Now, when do I stop? And I'll talk about that in a minute. So first, I'm going to choose 0, then 0.5, then 0.9, 0.99. I'm going to get as close to 1 as I like, but I can't substitute 1 because if I substitute 1, I get 0 over 0, which is undefined. So the goal is for me to figure out what is y reaching. I was at 1, now I'm 0.666. If I take my answer minus 1 divided by, so basically instead of the x, use answer. And you notice answer now is 0. I got the first value. When I want to test 0.5, on your calculator you had a back arrow. It takes you back to this. I'm sorry, I missed that. So you plug in 0.5 and you enter. Now 0.5 stored in your calculator. On a scientific calculator, you click the arrow twice. In our case, you do it twice. Now, it's true I'm recalling answer minus 1 over answer squared minus 1, but now 0.5 is stored in my answer. I'll get 0.66 right there. So instead of doing 0.9 minus 1 over 0.9 squared minus 1, now all what I have to do is go in and type 0.9 and store it in my answer. Hit the back arrow twice on your calculator. 0.5263. 0.5263. So I was at y was 1, then 0.666, then 0.526. Now when do you stop? When these numbers are super close. How close? As close as you like it. If I test 0.99 in my answer, and I would go ahead and hit the back arrow twice, 5025. 5025. So it's leveling off so far next to 0.5. That's very good. But I want to be more accurate. I want to be certain as x approaches a value, y is reaching this number, and I don't want any doubt. 0.525. 0.525. Okay, now it's accurate to two decimal places. So now I see the y is leveling off next to 0.50 so far. Let me make sure that that's the case. So if I test 0.999, so the idea of a limit is I can't use the number, but how close can I get to the number? 0.525. You notice these numbers are almost the same. Okay, so if I round, well, that looks like a 0. It looks like 0.500. Now, if they say find the limit, I did the bottom. Now I want to do the top. So let's see how this works. Meaning what? Meaning I was looking at 1. So again, we know at 1 it's undefined. I'm trying to figure out how close can I get to 1. Well, let's go above. How about 2? And then 1.5 closer. 1.1. 1.01. So I'm trying to get as close to 1 as I can without actually using 1, because that will make it undefined. Now, again, everything's still in my calculator. If I am to go ahead and say, well, let's type in 2, and turn out store 2 in my calculator, in my answer, that's 0.333. And if I go for 1.5, that's closer to 1. 0.4 flat. Oops, no, just 0.4. How about 1.1? 0.46, no, 0.47619. 47619. How about 1.001? Nope. Well, let's 1.01. 497, 512. 497, 512. So again, this doesn't tell me much. This is accurate to 1, still accurate to 1. How about 1.001? Hit the back arrow twice. 0.499750. Okay, that's not bad. Why? Because now it's accurate to two decimal places. Just to be sure, one more number. And go back the back arrow twice for 39775. If I was to say, what do you think this number is? Wouldn't you say 0.5 as well? If that's the case, we say, so, as x approaches 1. Now, do you notice in the green, we pick numbers to the left of 1? F of x approaches a half. And when we pick numbers above, do you see that we pick 2? And so approaching this from the right, we say as x as x approaches 1 from the right. That's what we call, well, f of x approaches 1/2. If those match, we say as x approaches 1, x squared minus 1, x minus 1 over x squared minus 1 approaches 1/2. And of course there's a way of writing that, but for now let's stick with it. So basically, if you want to say this, you say the limit as x approaches 1 of x minus 1 over x squared minus 1 equal 1. So now we're saying what we just did. If f of x is defined at x near a number, not at the number, near a number, like the one in the previous case, the limit as x approaches 1 of x minus 1 over x squared minus 1 equals 1/2. The limit of f of x as x approaches a equal L. That's what it means. It means that we chose x values very close to a on both sides, but not at the number itself, and f of x values became very close to the same number from both sides. So both sides have to agree. If I look at problem example 2, the same deal. I have this function, and I need to pick values close to -1. Well, let's go from the left. -2, -1.5. Again, I'm getting closer and closer to -1 from the left. -1.1, -1.01, -1.001. Now, how many numbers do I need? I have to look at the y's. Once they start matching to so many decimals, I'm in good shape. So I'm going to go here, and I'm going to type -2 for starters. Make sure you use this negative, not that minus. Now that's stored in my answer, but now I have to really write a new function. I'm going to take my answer and raise it to the 5th power plus 1, divided by the answer to the 9th plus 1. I already stored the -2 in there, so let me see what went wrong. Oops. Let me see what went wrong. I put a cosine instead of parentheses. So if I do that again, if I take, so let me see what's in the answer. Okay, you can see the calculator kind of titled with the screen. So if I take -2 enter, now it's stored in my answer. If I am to go ahead and take my answer raised to the 5th power plus 1 divided by my answer raised to the 9th power plus 1, I'm getting 060665. 060665. Okay, one number doesn't mean anything. This is x, and this is this mess. If I go for -1.5, so again, I'm going to get numbers very close to -1, but never use -1. -1.5. I'm getting 176,099. 176,099. So if I have a fuse that burns at -1, I want to know how close can I get to -1 and not burn it. If I do that again, 44,95,8. 44,95,8. Okay, well, I'm not getting anything. These numbers are not getting close in any way. So that means I have to go closer, -1.01. You'll know that you're done when the y values are infinitely close. 0.54448. It's getting better. This was way off from 0.621 to 4.99 to 0.5. How about negative 1.001? 55 4 fours and an 8. Okay, not bad. At least one decimal place. That's the first sign of relief. Five, 5, 5, 4, 4, 4, 4. Well, it seems I'm getting to 0.555 repeated. Now, to make sure, all what I have to do is go on negative 1 and pick values to the right. Well, I'm going to go with 0, negative 0.5, negative 0.9, negative 0.999, and see how that works. The hope is that these numbers get very close to each other and they match this. Otherwise, it doesn't work. So if I take now 0, it's still stored. I know that's a 1. Because if you put 0 there, you get 1 over 1, which is 1. Negative 0.5. Is 976.46. 976.46. Okay. How about 668,501? 668,501. Okay, not bad. Why? Because I'm trying to see if it's going to reach that number. Now, this might seem like a lot of work, but pretty soon when I say give me a number close to negative 1, you're gonna start with like a negative 0.9. 2 5s, 3 6s. That's very good. Why is that? Because it's leveling off next to what I want. And if I try the last number, 55,666. Oh, did I put? Oh, I did put the same number. No wonder. Wait a minute. Negative 0.9999. Much better. 3 5s. Okay, well, what do you think? Since those two match, I would say, again, this and that have to match. I'll say it looks like a 0.55555. I'm going to go for part C, then B. Here you notice we're picking numbers close to 3, but we're only approaching it from the right. Now that you're getting this, if I say give me a number to the right of 3, hopefully you're not going to say 4 anymore, because you see how close we're going to get to these numbers. So 3x plus 2 over 3 minus 2, 3 minus x. I don't know what is wrong here. I don't know what's wrong with me. That's an x. There we go. So if I say give me a number to the right, let's say with 3.5, 3.1, 3.01, 3.001, and 3.0001. Well, let's see how that works. I need to input the new function. So I need, first I'm going to start with a 3.5. So I need to input that. There it is. And now if I take my answer plus 2 divided by my answer minus, no, 3 minus the answer. Negative 11. If I go to 3.1, again, in your calculator, you enter, you hit the back arrow twice. That's the same as what I'm doing on this calculator. Negative 51. Okay, I'm hoping this will level off next to a number. How about 3.01? negative 501. How about 3.001? Negative 5,001. Well, if you're not seeing it, you keep on picking numbers on the homework until you see it. Until you're confident that this number is reaching 50,001. So do you see that this is getting bigger and bigger in the negative side? So what do you think that's going to approach as I get closer and closer and closer? It looks like it's going to approach negative infinity. So again, we're trying to figure out what the y is doing by picking numbers as close to 3 as you would like. Now, one thing that comes up that's a bit tricky, it's trig. Pi's. Multiple of pi's are an issue. The reason they're an issue because pi is an irrational. Pi over 2. If I say, give me a number to the right of pi by itself, let's go with pi. Pi is roughly 3.14. Yes, that's fine to get an approximation. But if you write the number pi out, it's 3.141, and there are a bunch of numbers. When I say x approaches pi from the left or the right, there's an issue there. Because I can't say 3.1, 3.01. That's not true. That's not close to pi. So instead, I use the trick of, well, pick pi. And notice this is called a one-sided limit, which means you don't have to pick numbers at the left and the right. They only want to pick points to the left. So if I told you give me a number to the left of 3, normally let's say you're going to pick 3.1. Oops, to the left. You're going to pick 2.9. Isn't that 3 minus 0.1? With multiples of pi, that's how you play the game. And if I want to get closer than 2.9, if I told you 3, wouldn't you say 2.99? Isn't that 0.01 below 3? So again, pi over 2. And that's how we pick numbers as close to our limit as we like. And in my calculator, I want to make sure I am in radian mode. Otherwise, it doesn't work. It isn't radian mode. Okay, good. So now I'm going to go in and I'm going to take, so secant of theta, I'm going to take pi over 2 minus 0.1. That's the first value I stored in my answer. Now if I go ahead and take the secant is 1 divided by the cosine of the answer. So you have to make sure you're in radian mode, otherwise it doesn't work. 1.01247. 1.01247. If I get a bit closer, again, one value is useless. So if I take pi over 2 and I subtract off 0.01 and I do my evaluation again, 100.001. 100.001. Okay, well, jumped really drastically. If I go to another, let's say pi over 2 minus 0.001, what would happen now? If it's going to get, like bigger, then I'll know it's approaching infinity. Oops. 1.000. Okay, I must have messed up somewhere. I'll double check. 1.0, 1, 2, 3, 4, 5 zeros. Wow, okay. Then this number, probably I made a mistake. Let me double check it. If I take pi divided by 2 minus 0.01. Maybe I put a plus, I don't know. Okay, 100, that's still working the same way. Let me see, what is that? 100.001. Okay, then I need another number. If I take pi over 2, that's odd. Okay, that's very close to pi over 2 from the left. If I want to go ahead and evaluate again, oh, something's not right. Okay, what is not right? Alright, well, this is what I'm going to say. I'm going to say in this case, since these numbers are not leveling off next to anything, I'm going to say this limit does not exist. I don't know what it is, that's what I'm saying. There's no way of figuring that out. Here, things are getting negative 11, negative 51, negative 501, negative 5,001, negative 50,001. Here, numbers are leveling off next to a number, but on this, it's very confusing. I'm not sure why it's not working, but it's not. So I can't predict it. You can't say, hey, the limit is 1, and if you go a bit closer to the x, y jumps from 1 to 100. Something's not right. Okay, I figured out what's wrong. I was hitting this minus, this negative instead of this minus. This you use only if you're starting with a negative. So if I go back to the first number, so I messed up on these numbers, I see now. And it must have been this number as well. So if I was to go ahead and take pi divided by 2 minus 0.1. The first number is 10.016686. 10.016686. If I go for the next number, I get 100. If I go for the third number, pi divided by 2, not this negative, this minus 0.001. And if I evaluate that again, 1,000. Okay, it's getting better. And if I go for this, it's 10,000. So this is approaching infinity. So writing down what we just did. If you pick numbers to the left, so that if the function f is defined near a, then the limit as x approaches a from the left equal L, that's what we just did, means that we choose x values very close to a but less than a. And from the right, obviously it's the same thing. Now, if you say a limit exists, then you're saying that the limit from the left and the limit from the right give you the same y value. And if those don't match, we say the limit doesn't exist. For example, this is example 3. Suppose the following tell you, so you have this function g, whatever that is. You take the limit from the left of 0, you get a 1. You take the limit from the right of 0, you get a 3. What's your conclusion? Limit as x approaches 0 of g of x. My conclusion is that it does not exist. And this is the first lecture of this section.